Welcome to this deep dive. Today, we're tackling something that, well, it really affects everyone who steps outside UV radiation.
That's right. It's invisible. You can't feel it, but the impact is definitely real.
We've gathered a whole lot of information, research papers, guidelines from big names like the World Health Organization, the EPA, the FDA.
And practical advice, too, from groups like the Cancer Council, especially relevant when you think about places, say, like Australia.
Yes, Australia. They have some of the highest skin cancer rates in the world, don't they? It really brings it home.
It certainly does. It highlights why understanding this is so critical.
Exactly. So our mission today is to cut through all the scientific jargon, all the noise, and pull out what you really need to know to stay safe out there.
We're basically aiming to distill the essentials. What does the science say? What are the practical steps so you feel informed without needing a science degree?
Perfect. So let me ask you, the listener, have you ever looked at the weather forecast, seen that UV index number, and just kind of shrugged, not really knowing what it means for you?
Or maybe you're a bit confused about sunscreen. When do you actually need it? How much? How often? Does brand X work better than brand Y?
If that sounds familiar, then yeah, this deep dive is definitely for you.
And it's not just about avoiding, a painful sunburn after a day at the beach.
No, the sources are really clear on this, aren't they?
Absolutely. The long-term stuff is serious. We're talking different types of skin cancer, significant damage to your eyes, even messing with your immune system.
So understanding the UV index isn't just like a bit of trivia, it's a proper tool.
A practical tool for making decisions that genuinely impact your health down the line.
Okay, let's start right at the beginning then. What exactly is this UV radiation stuff?
Right. So sunlight hits the earth and it's made up of different kinds of energy, different radiation. We feel the heat, that's infrared. We see the light, visible light. Mm-hmm. And then there's ultraviolet or UV, invisible to us. Mm. But it's there.
And UV itself isn't just one thing, is it? The sources break it down.
Correct. It's categorized into three main types or bands based on their wavelength. UVA, UVB, and UVC.
UVA, UVB, UVC. Got it. Longest wavelength to shortest.
Exactly. UVA is the longest. UVC is the shortest. And generally, the shorter the wavelength, the more energy it packs and the more potential for harm.
Okay. Higher energy sounds bad, but thankfully our atmosphere steps in, right? Acts like a filter.
It does. And it's a very good filter, particularly for the really high energy stuff. The atmosphere is like ozone, oxygen, water vapor. It absorbs all of the UVC.
All of it. That's good news.
It's crucial. UVC would be incredibly damaging if it reached us in large amounts, so we're completely shielded from that.
Phew. Okay, what about the other two, UVA and UVB?
Well, the filtering isn't quite as complete there. A lot of the UVB gets absorbed, especially by the ozone layer, but a portion still gets through. Maybe around 10, 20% makes it to the surface, depending on conditions.
Right, so some UVB reaches us, and UVA.
UVA. That's the one that mostly gets through. The atmosphere doesn't block it nearly as much. Most of the UVA radiation makes it down to us.
Okay, so we're mainly dealing with UVA and a smaller chunk of UVB hitting the ground, hitting us.
Precisely. And that difference in filtering is key to understanding what they do to us.
Let's talk about that damage then. We know sunburn, obviously, but it's more than that.
Oh, much more. The sources hammer this home. Both UVA and UVB cause damage. At the cellular level, damaging DNA. Sunburn, the immediate redness and pain, that's mostly UVB.
Right, UVB for burning, I remember that one, affects the top layer of skin.
Yep, the epidermis. It's very efficient at causing that immediate burn reaction, and it's a major cause of the DNA damage linked directly to skin cancer in that top layer.
Okay, so what about UVA, the one that gets through more easily and goes deeper?
UVA penetrates down into the dermis, the layer underneath the epidermis. And because it doesn't usually cause that immediate ouch of a sunburn, people often underestimate it.
The long-term effects are serious.
Very. UVA is a major player in what we call photo itching. It breaks down collagen and elastin, the stuff that keeps your skin firm and springy.
So wrinkles, sagging, that leathery look.
Exactly. Uneven pigmentation, blotchiness too. UVA basically speeds up the skin's aging process. Think UVA for aging.
UV for aging, UVB for burning, got it. But UVA isn't just about aging, right? It's linked to cancer, too.
Absolutely. Critical point.
Yes.
While UVB might be the main direct mutagen for many skin cancers, UVA contributes significantly. It can cause DNA damage indirectly through creating unstable molecules, oxidative stress,
Okay.
and it can also suppress the skin's immune response, making it harder for your body to find and fight off those damaged, potentially cancerous cells.
Wow. So they're both bad news, just attacking in slightly different ways.
Correct. Different primary targets, different immediate effects sometimes, but overlapping serious long-term outcomes, including cancer.
Okay, so tracking both UVA and UVB levels sounds complicated. How do we simplify this? This is where the index comes in.
Precisely. The Global Solar UV Index, or UVI, this is a big international effort, WHO, World Meteorological Organization, back in the 90s.
And the goal?
Public health. To take all that complex science about UV levels and boil it down to one simple number, a number that tells you right now, right here, what's the UV situation and when do you need to take precautions.
So it combines the effect of the UVA and UVB that are actually reaching us.
Yes, but it's clever. It measures the intensity of the UV, weighted by how effective different wavelengths are at causing sunburn, what scientists call erythema.
Erythema, that's the reddening, the sunburn.
Exactly. So the calculation gives more weight to the UVB wavelengths because they're much more potent at causing sunburn than UVA.
So the UVI number reflects the immediate sunburn potential more strongly.
That's the core idea. It gives you a measure of how quickly you might burn. Then that weighted value is scaled into the simple UVI number, usually 0 upwards.
And this calculation, it has to factor in all those things that change UV levels, right?
Oh, absolutely. It incorporates several key environmental factors.
Like how high the sun is in the sky, sun elevation.
Definitely. Higher sun means the rays punch through less atmosphere, less filtering. So UV is strongest around solar noon, usually midday, 12 to 2 p.m.-ish.
And lower sun, early morning, late afternoon.
Means the rays travel through more atmosphere, more gets scattered or absorbed, lower UV. That's the daily cycle.
Makes sense. What about where you are on the planet? Latitude.
Big factor. Near the equator, the sun's generally higher all year round, so consistently higher UV levels in the tropics. Further towards the poles, the sun's angle is lower on average, less intense UV.
Okay. And altitude. You mentioned that earlier, going up a mountain.
Increases UV exposure significantly. Less atmosphere above you to block the rays. The source is, quote, roughly a 10 to 12% increase in UV intensity for every 1,000 meters you go up.
10 to 12% per kilometer. That adds up fast if you're hiking or skiing.
It really does. It's why high altitude locations can have surprisingly high UV, even if it feels cool.
Didn't you mention some crazy high reading somewhere?
Yeah, there was a record measurement noted in the sources, a UVI of 43.3 in the Bolivian Andes back in 2003. Very high altitude, near the tropics.
43. That's unbelievable compared to the numbers we normally see.
It is. It's an extreme example, obviously not typical, but it shows what's possible when factors combine. Really highlights the altitude effect.
Definitely. Okay, what about clouds? This is the one everyone gets wrong.
Yes, the big myth. It's cloudy, I don't need sunscreen. Wrong.
So what's the reality?
Thick, dark storm clouds. Sure, they block a lot of UV, but light, hazy, or broken clouds, they don't block much at all. Up to 80% of UV can still get through light cloud cover.
80%.
And sometimes, scattered clouds can actually increase the UV reaching you because of reflection off the sides of the clouds. It's complicated, but the bottom line is, cloudy doesn't mean safe.
You can definitely burn on a cloudy day. Message received. What about the ozone layer?
Ozone in the upper atmosphere is our main shield against UVB. But ozone levels fluctuate naturally with season, latitude, even day to day. If ozone levels are lower, more UVB gets through and the UVI goes up.
Okay. And the last factor you mentioned, reflection, albedo.
Right, albedo. How much UV bounces off the ground or surfaces around you. This reflected UV adds to the direct UV from the sun.
And it can hit you from weird angles.
Exactly. Under your chin, up your nostrils, tops of your feet, places a hat might miss. Different surfaces reflect differently.
Like what? Give us some numbers.
Snow is the big one. Fresh snow can reflect up to 80% of UV. Huge amount.
80%? No wonder snow blindness is a thing.
Absolutely. Seafoam or dry beach sand, maybe 15 to 25% reflection. Even concrete reflects a bit. So beach day, ski trip, you're getting it from above and below.
That explains why eye protection is so vital on snow. It's coming at you from all directions.
Precisely. Understanding these factors, sun angle, latitude, altitude, clouds, ozone reflection, helps make sense of why the UVI can vary so much and why it might be high even when it doesn't feel scorching hot.
Okay, so we know what UV is, the damage it does, and what affects the intensity. Now, let's decode that UVI number itself. What do the actual values mean? A3. a 7, an 11.
Right, the scale. It's pretty straightforward. It starts at 0, goes up. Higher number means stronger UV, means less time needed for damage to occur.
And there are categories to make it easier.
Yes, the WHO and EPA define standard exposure categories. Makes it really practical.
Let's run through them. Low.
Low is a UVI of 1 or 2. Risk is minimal for most people with, typical short exposure.
Right.
That's UVI 3 to 5. Now the risk is moderate, and this is where protection recommendations start kicking in.
High.
UVI 6 and 7. Risk is high. Protection is definitely needed. No ambiguity here.
Very high.
UVI 8, 9, and 10. Risk is very high. Need to be extra careful. Use multiple protection methods.
And finally, extreme.
That's anything 11 or higher. Extreme risk. All protective measures are essential. Minimize time outdoors if you can, especially during peak hours.
And these match up with the colors we sometimes see in forecasts. Green, yellow, orange.
Exactly. Green for low, yellow for moderate, orange for high, red for very high, and purple or violet for extreme. Standardize visual cues. Quick glance, you get the risk level.
Out of all those numbers and colors, what's the single most important threshold for people to remember?
3. UVI 3. That's the magic number according to the health guidelines. When the UVI hits 3 or higher, protection is recommended.
So it's not just about those scary reds and purples. Even the moderate yellow zone means take action.
Absolutely. That's where the risk starts becoming significant enough that consistent protection makes a difference to your cumulative dose.
You mentioned cumulative dose. So even at lower UVI levels, say UVI 2, if you're out for a really long time.
Yeah, that's a good point. While the risk per minute is low at UVI 1 or 2, if you spend, say, 8 hours gardening, even at UVI 2, that exposure adds up. So protection advice depends on both the intensity, UVI, and how long you're out. Higher UVI just means the damage happens much, much faster.
Right. More protection needed for higher UVI and longer exposure. Okay, so what is that protection? The sources talk about layers, right? Not just one thing.
Yes, definitely a multi-pronged approach, often called the 5 S's or a hierarchy. Sunscreen is one S, but it's not the only one, and maybe not even the first you should think of.
Let's list them out. What's usually top of the list?
Slip-on protective clothing, long sleeves, long pants, tightly woven fabric. It's a physical barrier. Yeah. Very effective. Some clothes even have a UPF rating, like SPF for clothes.
Okay, slip-on clothing. Next.
Slop-on sunscreen. Broad spectrum, SPF 30 or ideally 50 plus max, applied generously to any skin that's not covered by clothes.
Slap on sunscreen. Then next.
Slap on a hat.
Yeah.
And make it a broad brimmed hat, not just a baseball cap. You need shade for your face, ears, neck, a brim all the way around. Yeah, at least 3 inches ideally.
Slap on a hat. What else?
Seat shade. Especially during those peak UV hours, roughly 10 a.m. to 4 p.m. Under trees, umbrellas, awnings. Get out of the direct sun.
Seek shade. And the last S.
Slide on sunglasses. Protect your eyes. Make sure they block 100% UVA and UVB. Wraparound styles are best because they stop UV sneaking in the sides.
Slip, slop, slap, seek, slide. Using all or most of those together gives the best defense.
That's the idea. It's a combined strategy.
You mentioned peak hours, 10 till 4. Is there a quick way to judge if UV is high without checking the UVI forecast? Like if you're caught out?
There is. The shadow rule. Mm-hmm. It's pretty neat. Low tech.
How does it work?
Look at your shadow. If your shadow is taller than you are, the sun is low, UV is generally lower, early morning, late afternoon. But if your shadow is shorter than you are, the sun is high overhead, UV is intense. Midday-ish, that's your cue. Shadow short, seek shade, and use protection.
Shadow short, seek shade? I like that. Very practical. Okay, let's really dig into sunscreen now. It's probably the method people use most, but maybe understand least. What's its proper role?
Crucial point. Sunscreen is part of the strategy applied to skin you can't cover otherwise. It's not a license to bake in the sun or extend your time outdoors beyond what's sensible.
Right. The sources are really clear. Don't use it to deliberately get more sun.
Exactly. Its job is to filter UV before it hits your skin, supplementing the other layers like clothes and shade.
Okay, SPF, sun protection factor. What does that number actually tell us?
Primarily, it tells you about protection against UVB, the burning rays. And SPF 30, in theory, means it takes 30 times longer for your skin to start reddening compared to no sunscreen.
In theory, under lab conditions.
Precisely. Real-world use is messy. How much you apply, sweating, swimming, rubbing off, it all affects performance. So don't think of it as a timer.
What about the filtering percentages? That seems more concrete.
It is. Applied properly, SPF 15 blocks about 93% of UVB. SPF 30 blocks about 96.7%. SPF 50 blocks about 98%. SPF 100 gets you to about 99%.
Huh. So the difference between SPF 30 and SPF 50 is actually quite small in percentage terms, only about 1.3% more filtering.
Correct. The curve flattens out. Both SPF 30 and SPF 50 offer excellent UVB protection if you use them right. The slight edge with SPF 50 might provide a small buffer if you don't apply quite enough or reapply perfectly on time.
So using enough and reapplying is more important than chasing super high numbers.
Absolutely. And in places like Australia, SPF 50 plus is the recommended standard now.
And broad spectrum, why is that label so important?
Because broad spectral means it protects against both UVA and UVB. We know both cause damage, UVB burns, and causes cancer. UVA ages skin and also contributes to cancer. You need protection from both.
If it's not broad spectrum, you might stop the burn but still get hit with aging UVA rays.
Exactly. You get a false sense of security. Always choose broad spectrum. This is vital even for darker skin tones, which have less natural defense against UVA.
Okay, so baseline. SPF 30 minimum, ideally 50 plus, off, always broad spectrum. What else matters when picking a bottle?
Water resistance is key if you'll be swimming or sweating. Look for 40 or 80 minutes resistance, but remember you still need to reapply after toweling off.
Great.
Consider your skin type too. Sensitive skin? Maybe look for fragrance-free or mineral-based ones with zinc oxide or titanium dioxide. They tend to be gentler.
Mineral versus chemical sunscreens, yeah.
And check the expiry date. Old sunscreen might not work properly. Store it out of extreme heat like a hot car dashboard. If you react badly, talk to a pharmacist or doctor.
Now, there's sometimes chatter, online or elsewhere about sunscreen safety, chemicals, nanoparticles. What do the big health organizations say in the sources?
They're pretty clear and consistent. The overwhelming scientific evidence shows regular sunscreen use prevents skin cancer, especially the nasty ones like melanoma and squamous cell carcinoma.
And the safety concerns.
Regarding ingredients, including nanoparticles and mineral sunscreens, the consensus from regulatory bodies and health orgs is that, based on current evidence, they are safe when used as directed on the skin. They don't appear to penetrate healthy skin in significant amounts.
So long-term studies haven't shown harm?
No. Studies, particularly from places like Australia with high long-term usage rates, haven't found evidence of harmful effects from regular lifelong use. The message is really strong. The known, proven benefits of sunscreen in preventing cancer far outweigh any theoretical or unproven risks.
That's a really important message. Okay, so sunscreen is safe and effective if used correctly. And that correctly part involves how much and how often. The standard advice is reapply every 2 hours, right?
That's the general FDA guideline, yeah.
Yeah.
But the sources we looked at add a lot more nuance. It's often not every 2 hours in reality.
What makes you need to reapply sooner?
Well, activity is huge. Swimming, sweating heavily, toweling off, boom, sunscreen's gone or compromised. Reapply immediately after that, no matter if it's only been 30 minutes.
Okay, physical removal. What else?
The UV intensity. The UVI level. If the UVI is really high, say 9 or 10, your skin is getting bombarded much faster than if it's UVI 3.
Yeah.
Any gaps in coverage or slight thinning of the sunscreen layer become problematic much quicker.
Right. So higher UVI might mean more frequent reapplication needed.
Potentially, yes.
Yeah.
And this is where skin type comes in, using the Fitzpatrick scale.
Yes. The scale from type I, very fair, always burns, up to type 6, very dark, never burns.
Exactly. It reflects the amount of natural melanin protection you have against UVB burning. And the sources link this to reapplication frequency based on the UVI.
How so? Give us an example. Say UVI is high, like 7. How often would fair skin versus darker skin need to reapply?
Okay, UVI 7, high risk. Someone with type I or 2 skin, very fair. Even with SPF 30 plus properly applied, the sources suggest they might need to reapply as often as every, say, 30 to 40 minutes to maintain protection, especially if they're active.
Every 30, 40 minutes. Wow.
Now, contrast that with someone with type V or V skin, dark skin. At that same UVI 7, they might only need to reapply every maybe 90 to 110 minutes, again, assuming perfect conditions otherwise.
That's a massive difference, almost 3 times longer for darker skin in that example.
It is. And at very high or extreme UVI, the gap can be even wider. Type 3 might be down to 20-30 minutes at UVI 9, while type VVI could still be over an hour, maybe 80-100 minutes.
So that every 2 hours rule is, well, it's a very rough average at best.
It really is. Your actual need depends so much on the UVI, your skin type, and what you're doing. You often need to reapply much more often, especially fair-skinned people in high UV conditions. It needs to be personalized.
And when should you put it on? Just as you're heading out?
Best practice is 15 to 30 minutes before you go outside. Give it time to bind to your skin and form that protective layer, especially important before swimming.
Good tip. Okay, let's bust some common sunscreen and sun myths directly based on the sources. Myth 1. A tan looks healthy.
Fact. Nope. A tan is literally a sign of skin injury. It's your skin cells producing more melanin in distress because they've been damaged by UV radiation. It's a defense mechanism, not a health badge.
Myth 2. Getting a base tan protects you.
Fact. Very little protection. A dark tan on fair skin might give you an SPF of, 4. Maybe. That's basically nothing against serious UV exposure and does zero to stop the underlying damage that leads to aging and cancer.
Myth 3. Can't burn on a cloudy day.
Fact. Totally false. As we said, UV cuts right through light clouds. You can easily get burned. Don't be fooled by the lack of bright sunshine.
Myth 4. You're safe from UV in the water.
Fact. Water offers minimal protection. UV penetrates water, and the reflection off the surface can increase your exposure. Plus, sunscreen washes off. Risky combo.
Myth 5. Winter UV isn't dangerous.
Fact. UV is lower in winter, sure, but it's still there. And if there's snow, that high reflection, especially at altitude, can make winter sun surprisingly intense. Skiers know this well.
Myth 6. Taking breaks in the shade resets the clock.
Fact. Shade is great, but UV damage is cumulative through the day. Ducking into shade helps reduce the total dose, but it doesn't erase the damage done while you were in the sun. Protection needs to be consistent when UVI is 3+ SAC.
Last one. If you don't feel hot, you won't burn.
Fact. Heat comes from infrared, sunburn comes from UV. You don't feel UV. Cool, windy days can be incredibly deceptive. You can get absolutely fried without feeling hot at all.
These myths are so pervasive, but the science is clear. Relying on feelings or old wives' tales is risky. Okay, so why does all this matter so much? Let's really drill down on the health risks again.
Because they're significant and largely preventable. Skin cancer is the big one. UV exposure is the number one cause.
And there are different types. Non-melanoma.
Right, non-melanoma skin cancers or NMSC, basal cell carcinoma, squamous cell carcinoma, super common, incidence is rising sharply. They're linked strongly to your total lifetime UV exposure.
So all those little bits of sun add up over the years.
Exactly. They're usually not deadly, but treatment, often surgery, can be painful, costly, leave scars, especially if you get lots of them on your face or hands. And those rough, scaly patches, solar keratoses, they're precancers caused by sun damage, can turn into squamous cell.
And then there's melanoma.
Malignant melanoma. Less common, but much more dangerous. It's the main cause of death from skin cancer. Its incidence is also shot up globally.
And the link to UV exposure for melanoma is slightly different.
Yes. While overall exposure matters, melanoma risk is particularly strongly linked to intense, intermittent sun exposure, the kind that leads to sunburn, especially getting severely sunburned in childhood or adolescence. Those blistering burns are really bad news for future melanoma risk.
So NMSC is more about the long-term total dose. Melanoma is more about those intense burning episodes, especially early in life. Is that a fair simplification?
It's a reasonable summary of the general pattern the sources suggest, though it's complex. Genetics, moles, also play a big role in melanoma. But preventing sunburn, especially in kids, is absolutely key for reducing melanoma risk later.
Okay, skin cancer is major. What about eyes?
Eyes are very vulnerable too. Squinting doesn't help much.
Short-term problems.
You can get photokeratitis or photoconjunctivitis, basically sunburn of the eye surface, often called snow blindness or arc eye. Really painful, feels like sand in your eyes. Usually temporary, thankfully. Caused by strong UV, often reflected.
And long-term eye damage.
Cataracts.
Yeah.
Clouding of the lens inside your eye, leading cause of blindness worldwide. Chronic UV exposure, especially UVB, is a major risk factor for developing cataracts. Maybe 20% of all cataracts globally are linked to sun exposure.
20%. Wow. So sunglasses aren't just for comfort or style.
They are essential health protection for your eyes. UV blocking sunglasses are non-negotiable outdoors.
And the immune system effect.
Yeah, UV radiation can suppress immune function, both in the skin and systemically. In the skin, this might let precancerous cells escape detection. Systemically, it could make you more prone to infections or trigger things like cold sores by suppressing the local immunity that keeps the virus in check.
Okay, the risks are clear. Skin cancer, eye damage, immune issues. Are there groups who need to be particularly careful?
Definitely. Babies and young children top the list. Their skin is so delicate, and sun damage early on massively increases lifetime risk, especially for melanoma.
And no sunscreen for the really little ones?
Correct. Under 6 months, the advice is strictly no sunscreen. Keep them completely shaded, dressed in protective clothing and hats. Their skin is just too sensitive and absorbent. For older kids, it's about diligent protection and teaching sun-safe habits.
What about people with darker skin tones? We mentioned they still need protection, but let's reinforce that.
Absolutely critical to repeat this. Yes, darker skin has more melanin, burns less easily, and has much lower rates of skin cancer. But lower risk doesn't mean no risk.
Cancers can still happen.
They do. And tragically, because awareness might be lower or they present differently, skin cancers in people with darker skin are often diagnosed later, at a more dangerous stage.
And the other risk.
Eye damage from UV, like cataracts and immune suppression, those risks are the same regardless of skin color. Everyone benefits from protecting their eyes and skin from excessive UV, especially at high UVI levels or during prolonged exposure. UVA protection is important for everyone too.
So sun protection is truly universal, but despite all this knowledge, getting people to actually do it is still a challenge.
It is. The sources point this out. People might know the UVI exists, but they don't really understand what a 3 or a 6 means for them personally. Or they still believe myths, like clouds blocking all UV.
And changing behavior is hard. The desire for a tan, for instance.
It persists, especially in some groups, even though we know a tan is damage. Plus, you see differences. Men often use less protection than women, for example. Habits and cultural ideas take time to shift.
So education is still key.
Hugely important. Things like the SunSmart Global UV app giving you real-time and location-specific UVI and advice are fantastic tools. School programs, consistent messages from doctors, public campaigns, it all helps chip away at the myths and build better habits.
Making it automatic, like checking the weather.
That's the goal. Check the temp, check the UVI, plan your protection.
Okay, let's pull it all together then. What's the big picture message from this deep dive?
The synthesis is pretty clear. UV radiation is a real cumulative health threat. Skin cancer, eye damage, immune effects, but it's largely preventable.
The UV index is our main tool.
It's the key tool for gauging the risk level. Simple, standardized, tells you when to act.
And acting means layers.
Exactly. Not just sunscreen alone, it's the combination. Shade first, if possible. Then slip on clothing, slap on a broad-brimmed hat, slide on sunglasses, and then slop on broad spectrum SPF 30 plus sunscreen to the bits left over.
Tailored to the situation.
Tailored to the UVI, how long you're out, what you're doing, and your own skin type. Remember that UVI 3 threshold, that's your trigger to start using protection.
And doing it consistently.
That's the absolute key. Making sun protection a regular habit whenever the UVI is 3 or more is the single best way to lower your lifetime risk. It's about playing the long game for your health.
Right, that really wraps up our exploration of UV, the UVI, and how to protect yourself, drawing on all those expert sources. We've covered what UV is, how the index works, the layers of defense, the details on sunscreen, the serious health risks, and why it's important for everyone.
The knowledge and the tools are there. It's just about putting them into practice.
So maybe a final thought for you, the listener, to take away. UV damage adds up quietly, often without you feeling it. How can you make checking the UV index and choosing your protection layers as automatic as grabbing your keys before leaving the house? Could you start thinking about your UV budget for the day, based on the forecast, and let that guide your choices about time outdoors?
It's about empowering yourself with this information.
Yeah.
Look at that UVI number, understand what it means for you, and use those layers of protection. It's a simple thing, but it makes a huge difference to your long-term health.
Thank you for joining us on this deep dive.